something outran the stars over Mars in October 2025. It began with a faint razor-thin streak captured by the Perseverance rover's night sky cameras, a startling 60 km/s flash that perfectly matched the speed and timing of the predicted Mars flyby of interstellar visitor 3I Atlas. Then, in a moment of simultaneous chaos, scheduled Mars orbiters suddenly went dark, and the raw images containing the streak vanished into an official silence. Unconfirmed reports began to leak out. Mentions of multiple fast objects, a mysterious green flash, and official data releases stalling just when answers mattered most. What happened in those missing frames? These clues, emerging from the heart of our solar system, could potentially rewrite what we know about interstellar visitors and the very nature of comets. The 60-kilometer streak. An amateur discovery. The timeline of the mystery starts on October 2nd, 2025. Stephen Burns, a widely respected amateur astronomer known for his technical rigor and skepticism, posted a night sky time-lapse compiled from the Perseverance raw image archive. The sequence, painstakingly stitched together from a run of consecutive frames, displayed a single razor-thin streak cutting across the Martian starscape. The key finding was its apparent velocity, calculated meticulously at 60 km/s. This speed immediately stood out, far exceeding any known meteor, Martian satellite, or cosmic ray artifact typically seen in rover data. For context, such speeds, consistent at Mars distance, are reserved exclusively for interstellar wanderers, objects unbound by the sun's gravity. Burns's methodology was methodical. He calibrated the frames against a fixed star catalogue, checked each timestamp, and measured the streak's motion relative to background stars frame by frame, ruling out any fixed camera artifact or cosmic ray hit. His calculation was clear. If the measured 60 km/s held up, the track matched the predicted sky motion of 3I Atlas almost exactly. His disclosure went viral, kicking off an intense, crowdsourced analysis across online forums. The digital battlefield, the green flash, and missing data. The amateur community seized the challenge, eager to reproduce or dismantle the finding. Within hours, hundreds of independent analysts downloaded the Perseverance frames. The debate quickly fragmented. Some reported success, claiming to spot not just the main track, but hints of secondary fast movers in the same data. Others running alternative pipelines saw only noise, leading to heated accusations of artifact hunting. The most explosive anomaly occurred at 0.03 UTC, when one group's animation revealed a brief, pixel-level green flash. The sighting triggered a cascade of speculation. Was it a real chemical emission event? Or a digital ghost, a cosmic ray strike amplified by aggressive image stacking? Without access to the original, unprocessed FITS files and camera telemetry, every claim was provisional. The lack of an official rapid data pipeline dump from NASA fueled intense suspicion. While some suggested this was the normal lag of moving target campaigns, others saw a deliberate cover-up. The signal's reality hung in limbo, its fate now tied directly to the upcoming Mars orbiter campaigns, which were expected to deliver decisive, independently verifiable images. The silence of the orbiters, the missing frames, for a brief window in early October. Mars became the solar system's best vantage point on an interstellar visitor. 3 orbiters, MRO with its high-rise camera, ESA's Trace Gas Orbiter, TGO, and Mars Express were all tasked to catch 3I Atlas at its closest approach, a distance of about 9 million km. The expectation was simple. If anything odd happened, fragmentation, jets, companions, these images would be the first to show it. The entire campaign required meticulous, calculated gambles, aiming the narrow fields of view ahead of the predicted path. Yet after the flyby, the silence was absolute. No raw images became the phrase echoing across every discussion. Normally, headline event data hits public archives within a few days, but this time, nothing arrived from HiRISE, Cassis, or Mars Express. The silence was not mere bureaucratic delay. Inside JPL, imaging teams faced a bottleneck of caution. For a target sweeping across the sky at 60 km/s, standard calibration pipelines break down. Every frame had to be manually checked for registration drift, cosmic ray streaks that might be misread as companion objects, and alignment issues that could create digital ghosts. The internal pressure was immense. Release too soon, and a digital ghost could ignite a global frenzy. Wait too long and accusations of cover-up multiply. The current delay is a bottleneck of caution, one that puts scientific integrity above speed. The world waited, knowing that the next release would have to settle the most urgent question. Did Mars's cameras catch a single nucleus, a cluster of fragments, or something that demands a new kind of explanation? The chemical paradox. Green glow. Without dicarbon, the mystery is deepened by the contradictory chemical hints. The reported green flash at 003 UTC implies the presence of dicarbon, C2, which emits a bright green signature when hit by sunlight, a reliable cometary calling card. However, early provisional spectra from Mars Express and TGO hint at the opposite. The expected C2 emission bands are weak or missing, replaced by a volatile mix rich in carbon dioxide, CO2, and depleted in classic carbon chains. In laboratory terms, a green flash without dicarbon is a contradiction. The glow, if genuine, demands a new mechanism or an exotic contaminant at work, challenging textbook comet science. The chemical paradox continues with the metal composition. Early reports from the Mars Express team highlight an emission fingerprint dominated by nickel, not iron. Nickel lines, usually faint, now tower over the spectrum, a reversal of what solar system comets display. Furthermore, TGO instruments recorded a volatile mix where CO2 outgassing dwarfs water vapor by an order of magnitude. For a comet heating up near the sun, water should lead, but here, carbon dioxide is king. Each oddity suggests an object that is chemically unique, perhaps pointing to an entirely different planetary formation process, or something else entirely. The dynamic impossibilities, anti-tail, and implied mass. The physical behavior of 3I Atlas also challenges all known dynamic models. Mars orbiter images, even at their coarse scale, hinted at a plume not trailing away from the sun, but blasting forward, an anti-tail, sunward, and sharply defined. The classic fan-shaped tail is missing. Instead, the plume's leading edge is unnaturally steep, its brightness gradient defying dust models. Dynamic simulations estimate that only a very large, very dense nucleus could sustain such a plume without being spun apart. This leads back to the question of mass. Tracking teams calculate the object's mass by monitoring for any non-gravitational acceleration, the tiny nudges caused by uneven outgassing jets. For 3I Atlas, the answer is a profound silence. Even with visible activity, its path hugs the predicted gravitational arc almost perfectly. The implied lower bound mass estimate is over 10 billion tons, making it more akin to a small asteroid than a comet. All these anomalies are logged and debated, with the scientific community weighing whether these signatures point to an object that simply rewrites the comet rulebook or something that can't be written off as natural at all. The cosmic overlap. A signal. From the WOW location, adding a layer of profound, unsettling context. Avilobe's team ran provocative orbital models, backtracing the path of 3I Atlas across decades to see if it might overlap with the source of the famous 1977 WOW signal, the 72-second radio burst at 1,420 milliwords. The hydrogen line. Using Monte Carlo simulations, they estimated the chance of such a sky position coincidence at about 0.6%. This is rare, but not impossible. The hydrogen line holds special weight in SETI circles, as nature doesn't broadcast in such a tight channel. Loeb's group argues that if any object deserved a targeted radio follow-up, it's one that passes through the WOW coordinates and moves at interstellar speed. With 3I Atlas now slipping behind the sun into a blackout zone until early December, the question lingers, will the next radio window reveal anything more than silence? Or will we find a faint, coded answer to a question asked nearly 50 years ago? The blackout period demands patience and rigor, with the entire scientific world watching the calendar, waiting for the crucial post-perihelion data to determine if this interstellar puzzle deepens or finally yields an answer.